Like you heard, my name is Caleb from Scup Aquaculture. We're a team of friends and designers and engineers and biologists. And our initiative focuses on equitable use of ocean space in the form of aquaculture infrastructure developed on offshore wind sites. We hope to manage and strengthen the relationships between traditional ocean industries and renewable energy developments. Our problem hinges on ocean resources. Globally speaking, we need more sustainable food, and we're running out of space in the ocean to produce it. So how can we build a future-facing circular food system offshore? This illustration is a quick glance into our solution. Our project focuses on growing mussels and kelp. So why seafood? Well, farming shellfish, finfish, and kelp is a cost-effective and renewable way to reduce our reliance on land agriculture systems. We've chosen mussels and kelp as resources because they already thrive in the offshore environment, and they're nutritious zero-input products, meaning they require no added feeds or fertilizers. This makes them a great candidate for circular production by eliminating the need for more products and reduces their environmental impact. Demand is only growing too. In the next 10 years, seafood will fall short of demand by a projected $14 billion. Now, while demand is high, production is getting more difficult. It's no secret that climate change and other human causes are the case. But in order to keep up with ocean acidification, which harms bivalve shell formation, heat waves, which killed 1 billion sea creatures in Vancouver last year, algal blooms, nutrient depletion, so on, we need to rethink our aquaculture. By moving these farms further offshore, we can diversify against the impact of climate change on inshore growing and take advantage of better growing conditions. Now, with all that being said, it's easy to think that climate change is the biggest obstacle out there to fisheries and sustainable ocean uses. But in order to consider sustainable offshore solutions, you need to have space to do it, which becomes a big issue. We always hear about how many gigawatts a proposed wind farm will produce, but rarely about the physical size of the farm. By estimates based on land wind farms, 1 square kilometer of space can support about 4 megawatts worth of wind energy generation. In the United States, the current 30 gigawatt development plan for offshore wind could translate to around 7,500 square kilometers of ocean space used, which is almost 3,000 square miles. This map shows just a few of those future sites planned in the Atlantic under the Bureau of Ocean Energy Management. Now, if you're a fisherman, that's a scary thought, because in an industry already facing climate, economic, and labor challenges, getting shut out of an area the size of Puerto Rico is more than just an annoyance. Wind farm space is effectively unavailable to other commercial uses for a number of reasons, and the ocean as a whole gets busier every year. And it's not just wind farms either. Looking at this map, for example, which covers around 100 square miles of the North Sea, you can see that it's really just a complete mess. This map shows features such as shipping lanes, zoned commercial areas, economic zones, pipelines, energy sites, undersea cables, protected areas, and more, all of which restrict ocean use. Food production in the ocean is always going to tend to lose against economically powerful energy companies and other companies when vying for space. So it's clear that unless offshore wind developments are thoughtfully designed to accommodate existing ocean industries, there's going to be some fierce competition. And there's already a strained relationship between fisheries and wind farms as it is. So 2 important industries, sustainable energy and aquaculture, both losing. However, we have a plan for them to coexist. So here's our solution, a growing platform that harvesters can use on offshore wind farm sites. In the US, our oldest operating offshore wind farm is here in Rhode Island. So a pilot program for that some of the constraints we work with. Throughout, we also need to replicate current growing practices as closely as possible to keep harvesters' barrier for entry low. When our platforms are developed and ready to go, our primary role will be to manage and coordinate the relationships between wind farms and harvesters. A key reason that plans like ours have never seen full-scale operation is the complexity of those relationships. If you're a wind farm, you have liability and insurance concerns about other operations nearby impacting your structure. And as a harvester, you have concerns, for example, about how being offshore will change your operations. And for both parties, navigating the permitting process for a multi-use site is a new and time-consuming process. So as hired consultants, we will fill that empty niche in personnel and expertise. Now, one of the most exciting parts of our role is that we get to act as project coordinators and get to communicate with all the stakeholders to ensure that their needs are being met. We've been in long-term contact with several parties on all sides, including offshore wind developers, Rhode Island-based shellfish and seaweed harvesters, permitting authorities, folks that are in oceanic and atmospheric administration. And these conversations have really helped inform our design, as well as just show us that it seems like everyone we talk to is full of support and really excited about overcoming this wicked problem. Some of our main partners so far are American Mussel Harvesters, Matunic Oyster Farm, Everything Seaweed, Point Judith Kelp Company, and Orsted, the owner of our local wind farm. And they're all really important to us, since harvesters and wind farms are our two biggest stakeholder groups. We also have a number of project advisors, some of whom are listed on screen. They're researchers, industry representatives, government officials, a really diverse crowd of people just helping to make this work. Now, we created our design with those stakeholders at the center. You can see some earlier versions of the platform on screen, and every change we've made is really just based on feedback from them and from our many advisors. For example, the ring shape is a response to sea conditions and concerns about species entanglement that are issues with more traditional long line aquaculture or cages like you see pictured. The continuously looping mussel rope is an adaptation to standard harvest techniques, for another example. Now, moving forward with additional funding, our primary goal is working towards a 2-year pilot program off the Block Island Wind Farm in Rhode Island. This would allow us to continue our iteration process while also conducting required environmental monitoring, which can secure the site for commercial shellfish production. As our prototyping and testing develops, these funds would be instrumental in making it all happen. So to wrap up, our vision of the ocean sector has various users working together in a challenging global landscape. We are part of a future with food security as we fight climate change, a future where ocean innovation empowers everyone, and where limited ocean space is democratized. Thank you all so much for your support, and let's go back to the studio.